determining true wind works a lot like everything else we're learning to do on MoBoards. Remember, the wind you experience when you're underway on a ship, when you're making way, is not indicative of the actual wind in reality. You're pushing through the water at a certain speed, so you've got a certain headwind that's pushing against you. It's just like, if you're riding a bike, you'll feel the wind against you, but that's not actually wind, that's air standing still, but its relative motion is coming at you. The same is true here, and so the apparent wind you experience is the vector sum of the combination of your vector and the vector of the true wind, and how the two of them interact. There are a couple different ways you can calculate it. You can calculate true wind. You can use what's called a wind wheel. It's a lot like a Starfinder. It looks like a Starfinder, but you align it to measure your speed versus apparent wind and stuff, and that will give you true wind. There's a table in Bowditch you can use too. That's actually the one I remember how to do the best. There's not much point in going over it, but you're basically just comparing the apparent wind in units of your ship's speed, and that will give you what the true wind speed and direction is. It's not that hard to figure out. I think you can do that on your own, or you can do a maneuvering board. And ultimately, the maneuvering boards are a lot like, if maybe a little bit different from any other MoBoard problem you're going to get. It's still just vector triangles. So we're going to do two examples for both determining true wind and then manipulating apparent wind for getting them in an ideal condition. But we'll start with just finding true wind. So let's say you're on course, 160 at speed 20 knots. Actually, 15 knots, yeah. ER. And let's say your true wind is found, or your apparent wind is 30 degrees on the starboard bow at 25 knots. First of all, we have to remember wind is described from the direction it's coming from, whereas currents are the direction it's going to. So wind that's on the starboard bow at 25 knots is not going this way at 25 knots. It's going this way at 25 knots. So you have to remember that is the vector, and the way the vector is pointing towards will be indicative of the direction that the wind is coming from. It still works. You just have to bear that in mind, because that's also going to apply for the true wind vector when we find it. So we said 30 degrees, so here's 10 degrees, 20 degrees. I'll zoom in here. 10 degrees, 20 degrees, here's 30 degrees. And we said it came out to, what did I say, 25 knots? Now, you would probably notice that, here's the 25, that this is not being set up in the same way that the vector triangles normally are, because your apparent wind is the relative motion, theoretically, between your course and speed and the true wind's course and speed. So this couldn't really be labeled EM. Realistically, this is RM right here, but you've got R here and R here. The triangle doesn't work. Or it's actually it's RM this way. And what that means is that the triangle doesn't really work in its construction, but I'll show you this, and you don't need to know how to do this because this is just to demonstrate. If we connect these two lines here, but then we were to move our apparent wind that we drew on this side and set it to the same length, right there, we would get the same thing. So this and this are the same. And if this is RM, meaning this is RM, you would get EM here. So this is actually EM as well. If that's what you prefer, if you want to set up the RM vector immediately off of the ER vector like we have in the past, that's totally fine and it will get you the correct answer. However, we set it up this way because I think it's, I mean, first of all, it's because that was the way I was taught. I'm aware, though, that this is kind of counterintuitive. It is sort of, in a way, though, more indicative of what you're visualizing, because you're visualizing the wind coming in from here while the ship is there. You kind of, the true wind almost feels secondary in this case. That's arbitrary. That's totally arbitrary, but that's how I was taught. Know how to do it either way in case your teacher wants this, but this makes more sense. Ultimately, though, you're still connecting these two vectors in a line. You have to remember that if relative wind is going from here to here, then true wind is going from here to here, just like it's shown in here. It's E to M. So we haven't actually measured what it is yet, but if we slide this over, what you want to do next is draw a whole nice line all the way across. Looks like we've got a true wind of 221 and a true wind speed. You bring it to the 5 times scale. A true wind speed of 14 knots. Okay, 14 knots. So if you were on course 160 with on a speed of 15 knots, and you had relative wind on the starboard bow at 30 degrees at a speed of 25 knots, your true wind would be 221 at, what did I say, 14 knots? Good. Let's try that one more time with another problem. And I'm not going to replicate this other triangle here because I want you to focus on just the one that I was instructed to make. So let's say we're on course 280 at 20 knots, and we had wind 25, because it doesn't always have to be on a 10, 25 degrees on the port bow at 10 knots. So we've got ER here, and this is technically RM. I think you could also just label this like relative or W for wind here. So let me mark that more clearly. So we'll connect the two like so. And remember, like in this one, even if you don't remember the directionality just intuitively, RM, or relative wind, was going from here to here. True wind is going from here to here. So both true and relative wind have their vectors starting at the same point. So whichever point relative wind begins at and goes the other way, that's the same way for true wind. So in this case, if relative wind is coming here going here, then true wind is coming here going here. So we'll move that over. From here to here. So we draw it all the way out here. We get a true wind of what, 288, and a speed of 12 knots. Okay. So in this case, we were headed 280 at 20 knots, and we had the relative wind on the port bow at 25 degrees on the port bow at 10 knots. Our true wind is going 288 at 12 knots, and that makes sense. Think about it. our relative wind is slower than our actual speed. So even though we're going 20 knots ahead, we're not experiencing 20 or more knots of headwind. For that to be true, the true wind would actually have to be blowing on our stern to almost counteract the force of our force through the air. And that's why the true wind here has to be less than and going with our true course to give us a slower apparent wind.